Previously, we solved this system using the method of substitution. Let me label these equations 1, 2, and 3. What we did was, we used equation 1 to write x1 as 1/2 x2. And then, for the other equations, we replace x1 with 1/2 x2. And so we obtain the following equivalent system. And then we apply the same method to this smaller system. Notice that we can rewrite this system as follows. And let me label these equations 4, 5, and 6. We now see how this system could be obtained from a different point of view. First, notice that we can obtain equation 4 by taking equation 1 and multiply both sides by 1/2. And we can denote that by the following. So 4 is given by 1/2 times 1. So this notation here means we are multiplying both sides of the equation by 1/2. Now to obtain 5, I can take 1/2 times equation 1 added to equation 2. And the way we write this is as follows. 5 is given by 1/2 times 1 plus 2. So this notation means here, you take 1/2 the left-hand side of 1 and add to the left-hand side of 2. And for the right-hand side, you take 1/2 the right-hand side of 1 and add it to the right-hand side of 2. And similarly, we can write 6 as 3 plus minus 3/2 times 1. The systems consisting of 1, 2, 3 and the system consisting of 4, 5, 6 are equivalent in the sense that they have the same set of solutions. In fact, we can obtain 1, 2, and 3 from 4, 5, and 6 using similar operations. And the operations performed here are called elementary operations. And there are 3 of them. These operations are sufficient to solve any system of linear equations defined over a field. The first operation is, as we have seen, multiplying both sides of an equation by the same non-zero constant. The second operation is adding a constant multiple of an equation to another equation. And if we look back here, we use the second operation to obtain 5 and 6. And the third operation, which we didn't use and is not really needed, is interchanging the positions of 2 equations. For example, if I write down the system, 2x1 minus x2 equals 0, 3x1 minus 2x2 plus x3 equals minus 2, and minus x1 plus x2 minus 2x3 equals 4, then these 2 systems are equivalent, and I have obtained the green system from the black system using the third elementary operation. Even though the third operation is not really needed, sometimes it's convenient to have when we solve by hand because it makes things easier to read.